Okay, question 14, part A here, part 1 of part A. Quotient, no, product, sorry, I'm mixing these up, aren't I? Product, because we multiply the function, so u is e to the x over 2, v is tan 2x, so du dx, differentiate e stays the same, times by the derivative in x over 2 is a half when you differentiate it. Here then, dv dx, now tan 2x, right, well, in the formula booklet, tan x becomes sec squared x, if you remember that, it's in the formula booklet, but that's what you get. So tan 2x then becomes sec squared 2x, you've got to then times it by the derivative, don't forget, function of function, times it by 2 then, so you get this. So then, if we do then the product rule, v du dx, so half e to the x over 2 tan 2x, plus then this times this, so 2 e to the x over 2 sec squared 2x, okay. Part 2 then, y equals cot 3x. Now, you might not be familiar with this, but it does come up. You've got to use the formula booklet, because in the formula booklet it tells you what cot x is. So look in your formula booklet, you never know, it might give you the answer. Now cot x, when differentiated in the formula booklet, is minus cosec squared x, okay? So it's there in the formula booklet, all clear. Cot x differentiated becomes minus cosec squared x. You just literally use that result, right? You don't have to think much. Okay, cot becomes minus cosec squared, now 3x obviously, okay, but don't forget you've got to use the same principle, same rules, differentiate then, it's a function of a function, so cot becomes cosec squared, but you've got to times them by the derivative there, which is 3, okay, so you've got to do that, and then check the 3 in the front, okay, and it's job done, right? It's really simple, but don't forget use your formula book because it's there for you. Right, part 3, y equals 1 over e to the power 4x minus 9. Remember, when things are on the bottom, you can't differentiate like this, you've got to take it up. Okay, so when you take it up, everything on the bottom becomes minus. Okay, so in effect, you could write that as minus bracket 4x minus 9. Okay, because you take it up, you change the sign of it. And then that would simplify to be minus 4x plus 9, right? So you could have done that straight away, but you just change the signs there. So when you differentiate then, that dy dx then becomes, well, e stays the same, doesn't it? Okay, so it's a nice simple straightforward function. E stays the same, we've got to times it then by the derivative in there, which is minus 4. Okay, and that's it. Okay, job done. You get your answer there. I mean, you might want to then put minus 4 there and then take that back down to get it as it was to start. Okay, easy peasy. Okay, next part then, part 4, y equals root 1 plus tan x. Okay, now it's a bit obscure, this type of question, but easily done if you think about it. This rewrite as a power half, okay, because it's square root, and then differentiate the outside function first, bring the power down, so that'll be half 1 plus tan x. Take away 1 from that, so you get minus a half, and then times then of course the derivative in here, which is sec squared x, because tan x becomes sec squared as we saw earlier. Okay, so then just tidy it up a bit, so you get sec squared x on the top, on the bottom then 2, and then you can rewrite that as 1, because if you take that down it'll be power half on it, so I can write that as a root, and it's done, it's sorted. So next question then, right, this one, unlikely to come up, okay, it doesn't come up, but if it does come up, okay, you know what to do now, because basically if you get this, okay, cos cubed x, so it could be cos squared x, right, or cos to the power 4x, could be any power, it doesn't matter. The principle you use, right, is straightforward. Just remember what we're doing here, we're cubing, right, and we write it like this because it's just easy in terms of notation. Another way, of course, of writing this is cos x in a bracket all cubed, isn't it? That's how we should think about it, really, when we say cos cubed x, don't we? And then just think, okay, well, how would I normally differentiate when you've got a bracket or power? Well, you differentiate the bracket and you bring the power down. Okay, so then reduce the power then, so you differentiate the outside function, differentiate the bracket, bring the 3 down, reduce that by 1, so it's a 2, and then you times it then by the derivative of the inside. Differentiate cos x, you get minus sin x. Okay, and that's it. That's all there is to it. We can simplify this a bit now. We can put that minus at the front. Cos x all squared then, well I can write that as cos squared x, can't I? Sin x, and that's it, right? It really is that simple. It's not difficult. So any question like that, when you've got a cos to the power, or tan to the power, sine to the power, any power, do it like this, right? Write it as a bracket with the power, differentiate the bracket, times it by the derivative, and you're done. Okay. Part B then, you've got y equals 1 plus tan x over 1 minus tan x. Okay. And it says show that dy dx is always positive. Okay. Well, if we write the top as 1 plus tan x and the bottom as 1 minus tan x, okay, du dx then will become, differentiate this, you get sec squared x, yeah, because tan x becomes sec squared x, 1 just goes. Differentiate this, you get, well, minus tan x becomes minus sec squared x, okay. So you do the product rule. There we go again, getting confused. You use the quotient rule, don't you? The quotient rule. Okay, so v du dx, that times that, minus, of course, then u dv dx. So we're taking it away, aren't we? Minus u dv dx. Maybe I'll write the dv dx bit first. All over v squared, so that's squared. Okay, now remember with quotient rule, keep the bottom as it is, because that's as simple as it gets, right? It's much better. The top can be multiplied out though, so you get sec squared x minus sec squared x tan x. Notice here now you've got two negatives, we've seen that already, so that becomes a plus. Sec squared x times 1 is sec squared x. Sec squared x times tan x is sec squared x tan x. Okay, so the sec squared x is cancelled with the tan x there. You can notice 1 minus 1 plus. So you end up having then 2 sec squared x over 1 minus tan x all squared. And then it says show it's always positive. Well, if you think about it, you know this, don't you? This is a square function on the top, times in by 2. That doesn't make any difference. A square function is always positive, isn't it? Square function here is always positive. So you can say, look, sec squared x will always be greater than or equal to 0. 1 minus tan squared x, tan x all squared, sorry, will always be greater than or equal to 0 because it's a square function. So then you've got positive over positive implies dy dx will always be positive, okay?